So again, we are trying to prove that ABC is equal to half the arc measurement of AC. But for this case, we have a point Q on the exterior of the angle, and Q is the center of the circle. So very similar to case 2, we're going to want to display our diameter of the circle. So we're going to make a line segment BD that goes through the center, and that is going to represent our diameter. And now we see that we can use case 1 to start to figure out what's going on and how we can prove this theorem. So we see that since we have the point on the angle, that ABD is going to equal half the arc measurement of AD. And similarly, we have that angle CBD is going to equal half the arc measurement of CD. And I will put that right there. And we also see that the angle ABD can be broken down into the sum of angles ABC and the angle CBD. And similarly, we can also say that the arc AD can be broken down into the sum of arc AC and arc CD, which we have here. And again, we are going to want to use substitution. We now have these two we know what these two angles are equal to, so we can start plugging that in. But the only difference between this case and case 2 we want to substitute is we first have to move some stuff around, because we're no longer looking for this larger angle. We're looking for one of the angles that is used to find the sum of it. So what we would do is, move some of the equation around. So we would, we're trying to get this angle ABC. So we would subtract angle CBD from both sides and find that angle ABC is equal to angles ABD minus angle CBD. And here we can use these measurements that we found over here and substitute that right in and find that angle ABC is equal to half the arc measurement of AD and minus half the arc of CD. So when we are looking at this equation and still trying to find that connection between arc AC and angle ABC, we see that we can also move this equation around and get that arc AD minus arc CD is going to equal that arc AC, which is what we have here. Therefore, we can conclude that angle ABC is equal to half the arc measurement of AC, which is what we were looking for, and this proves that the theorem holds.